my name is Tony Stedge. For those who don't know me, I work with the UX team as a UX designer. And something that I'm really passionate about has to do with understanding the physical world and the digital world and how we interact with the two. In particular, today, I'm going to be talking about what's known as the 40 pixel touch target. This is an idea that I'll go into depth about, but ultimately, I can say that when I first started in UX, I was told, hey, if you want to make something that's easy to touch, make sure that it's 40 pixels tall and you're going to be good to go. So today I'm going to debunk that myth a bit and talk a little bit about why, kind of where that came from and an alternative solution to be a little bit more precise with how we deal with touch targets. So, and as Archie said, there will be questions at the end. Please feel free to jot them down. I'd be happy to answer those as we go at the end of the conversation. So this is me. This is me on a hike, touching an old lantern on a hike. I just couldn't help myself. It looked kind of rustic and interesting to look at. But what I'm trying to display here is that we as human creatures interact with the world in many different ways. We interact by looking at things, we smell things, we taste things. And most importantly, one of the earliest things that we do is we touch things. The entire children's market of toys that you have all have to do with interacting and getting your hands on stuff, putting stuff in your mouth, at least in my case, and sometimes just making sure that the baby doesn't have stuff in their mouth, of course. But yeah, we interact with the world by touching things. And in particular, as we design and as we consider how our users use our software and our products, we need to make sure that the users can touch them and that it's a pleasing experience. Now, what do I mean by pleasing experience? Well, obviously, some things are more welcoming to touch than others. For those who are familiar, there's the Pillsbury Doughboy. He's the mascot for the Pillsbury brand for a while. I remember having a little plush of him and it being very soft and very welcoming to touch. He invited you to touch it. He would give a little giggle. In the other side of the spectrum, we have things that are not so nice to touch, not so pleasant to touch. For those, I don't know if anyone in middle school had those like prank gum holders that it had a piece of gum sticking up, but if you pulled it, it shocked you. Those are more surprising, maybe not in a good way, but things that are not so enjoyable to touch. So with that in mind, if we are designing solutions for people, we need to make the parts that are interactable, meaning the touch targets or the things that the user actually touches, we need to make those things welcoming. We don't want to make them difficult to do, especially if they are something that we want them to do on a regular basis. And we can also keep that in mind when it comes to designing things that we don't want them to touch. For example, if you had a big, the codes, the football, as they say, for the nuclear codes for the United States or whatever country, you don't want that to be an easy click of a button. You might want to design some interactions that are more difficult to do to make sure that the user clearly understands what they're doing. So by being conscious of our touch targets, we are going to make a better and more accurate solution for people and let them accomplish the goals we want them to do. Where did this all come about? Or first of all, let's talk about a touch target. For those who are not familiar, touch targets, we're going to define that as areas of a screen in our digital world, areas of a screen that respond to a user input. And we can break up touch targets into two different categories or two different ways of thinking. The first is a physical way of interacting with a touch target. So again, on your phone, depending on how hard you press, the angle at which you press the screen itself, you'll have a different amount of area, like in centimeters or inches, that you can measure that responds to that touch target. So when I say physical touch target, I'm talking about how much space in the real world in inches and centimeters that we can measure does relate to that particular touch interaction. The other side is the digital world. And this is how we often think about when we develop. This is how we think about when we design. And we are measuring in pixels. And that could range from a variety of sizes depending on the type of interaction we want. So again, touch targets, we're going to break it up today into physical world and digital world thought processes to understand a touch target. Where did this all come about? Actually, I was on TikTok. Of all the apps, of course, you can roll your eyes. I would say TikTok has a very, very nuanced understanding of my humor. But that said, I was on TikTok and I noticed a couple of interactions. I was either trying to tap something, I was trying to swipe something, I was trying to scroll, and there was something that that kind of frustrated me. It was an interaction that I wasn't expecting to happen, and this actually had to do with the touch target. What I mean by this, if you guys are on TikTok, you will understand my my world, what I'm explaining here. There's a feature that was rolled out a few months ago that allowed longer videos. And with the longer videos, there's this little white line that indicated that you could scroll and fast forward through a video. That's very useful. It's a very useful tool that they give to their users. But what I found is that if the video was like halfway through kind of what that image is showing, then that little tiny touch target was really difficult to target, meaning that that amount of pixels or the amount of inches that it took to actually precisely get that to be able to then scroll was so small that more often than not, I would click the button that's next to it, the either the inbox button or the create a new video button. It was just really difficult to target given that it was so small and so compact next to these other larger touch targets. Another example on TikTok, I was noticing when you go after you are on TikTok and you have other friends who are on TikTok, they want to invite other people or let you follow and interact with other people you know, or that maybe your connections know. I was trying to close out of that because I followed the people I wanted to follow. I wasn't necessarily looking to add these particular people. And I was trying to close this modal. I was trying to close this pop-up. And you'll notice that small X on the top right, I tapped on that button maybe like 10 or so times trying to get that closed. And what was registering on my phone or registering by the software were all these targets next to that X, but it wasn't until that 9th, 10th click that it actually registered and I got the right spot. And why did that happen? That touch target was too small. When the designers were designing this and the engineers implemented this, they chose a number of pixels that were too small that ultimately related to a physical size of inches and centimeters being too small for my fingers to interact with. So it's almost the opposite of a fat finger issue, but it's the same issue at its heart. The item was too either big or too small to basically not have the interaction you desire. Another example of this, I was on LinkedIn on my phone, just scrolling through stories, and there was one story in particular that I thought, I want to learn more. What are other people saying about this? And so I was trying to find the comments, and I tried to click on that comments, 46 comments here. And what did it do? I immediately clicked on the send button instead, and it brought me to the link to share the story out. That was not what I wanted to do. This touch target was too small. It was too close to these other buttons, which had a little bit more hierarchy or a little bit more priority. And so I was not able to have the interaction I wanted. The touch target was not doing what its function should be. Now, you could argue the designers did not have comments as the primary function here. Maybe they wanted to have send be more prevalent than comments. In either case, the spacing and the size of that particular touch target on my device was so small that, again, I would either click the send button or I actually also clicked on the image itself, which then expanded the image. Everything around what my target was, but my accuracy was not able to do what I wanted it to do because the touch target was too small. And one more example that you guys might have run into yourselves is on Zoom. Before the meeting joined, or before I joined the meeting, rather, I wanted to make sure that my settings were correct. I had headphones in connected to the phone. I also had, obviously, our cameras have front-facing and back-facing components to it. I wanted to make sure that everything was set up correctly. I'm not going to be looking, showing the rest of my room. I want them to be looking at my face. Just want to check my settings. But what might you notice about this settings button? One, it's a little small, and two, there are unclear bounds related to that particular touch target. And what do I mean by that? If you look at the background for this icon, it's the same background as the rest of the page. Now, that means that the actual interaction area, or the amount of space that I can tap to click that settings button, it's invisible to the user of how big that interaction could be. Hypothetically, that interaction could be all the way down the side of the page, or it could be just the width of that particular icon. Now, I know because I was tapping and tapping, it must have been a smaller interaction area, but ultimately, because of the way that that was styled as well, it wasn't clear that that I could get the touch target I wanted, if how precise I needed to be, and also it provided opportunities for me to mess up and actually click on the time part on the top left of the screen, which then was more of the hardware, the iOS settings that came down and brought my notification screen down. So again, because of the size, the position, and in this case, even the style, it wasn't clear to the user, to me, where I needed to tap in order to actually get this to work successfully. So those are my examples. I'm going to ask you guys to do a quick exercise. Obviously, I can't see you guys on your cameras, but I will trust that you will be following me along. So all you need for this exercise is a finger and your screen. Hopefully you have both of those if you are listening to me talk right now. So get your finger ready, your pointer finger. Doesn't matter if it's your primary or your less dominant hand. And what I want you to do is touch this green square. And using your interactions on the Teams, so you'll notice next to your more options option and chat option in Teams, please give me a thumbs up if you can touch the screen, or you can touch the square easily on your particular device. I see thumbs up, thumbs up. Awesome. Okay, cool. Now get ready. This is going to be like an eye test where I'm going to say, like, what about this one? What about this one? So get ready again. Here we go. And now, give me a thumbs up if you can touch this easily. If you would say that you could easily touch this. All right, thumbs up. Yes, I'm getting those thumbs up. All right, more thumbs up. Excellent. Thank you. Thank you. And one more time. Remember, I don't know if anyone wears glasses. This is a very familiar exercise. What about now? Thumbs up, please. Would you say that this is easy to touch on your screen? All right, I'm seeing some fewer. All right. And last one. All right. So having your finger ready. What about now? Would you give me a thumbs up if you would say that this is easy to touch on your screen? All right. And I'm actually not seeing any of them. And that's my experience as well on the hardware that I'm using. I'm on a fairly large monitor, but even so, this is quite small for me. Now, what does this mean? Somewhere in between this range of, in this case, 300 pixels, all the way down to 8 pixels in length and height, there has to be this magic size. There has to be the right amount of pixels that relate to a touch target that we can actually touch. There has to be a Goldilocks target size. And so what I mean by that is when we are designing for our users, we have to make sure we understand what is the actual touch target size we need to let the users do what we want them to do. Is the button going to be big enough for them? Is it, but at the cost of having a very blocky looking app. In WobTech, obviously, a lot of our products are very data driven. We want to show as many rail cars as possible. We want to see as many containers as possible. At least that's a lot of the feedback that we get. Yet if we're dealing with, particularly on mobile devices, where we're using our fingers to touch everything, we need to make sure that we have components that are big enough for the users to touch. But obviously, the bigger that component is, the less size you have to show your data, to show the number of containers, to show information about those containers. So what I'm going to do is tell you guys the secret to finding this Goldilocks magic touch target size. And to do that, we have to split up, again, the touch target into the physical world and the digital world. So what does research have to say about physical touch targets? Again, just inches and centimeters. How big should we make our touch targets? We have a couple of different research publications that we can look to. There was one by Parhi, Carlson, and Peterson that said anywhere from 9.2 millimeters to 9.6 millimeters. So roughly around 1 centimeter should be sufficiently large, is what they discovered for mobile apps. There was another study done by Liato and Silva that talked about a different demographic. For older users, having a little bit larger touch targets made sense because, one, there's a visual aspect to it. There's a motor aspect to that as well, being able to easily coordinate. And so for them, the touch target size actually needs to be a little larger, closer to 1.5 to 2 centimeters, or 14 millimeters to 17.5 millimeters. What about thinking about accessibility? Again, the mobility issue. There's a study for tetraplegic participants, and they found that instead of going exactly 9 millimeters, as the previous study said, they need to go a little bit bigger to make sure that the participants could get the appropriate interactions that were designed for that study. And overall, the consensus is that the larger the touch target size is, the higher performance and subjective satisfaction can exist for your app. So we're talking about a range from 9.2 to all the way to 17.5 millimeters. What are we going to use for us? What's just an easy number to go forth with? And for that, I propose that we use the gold standard set by Nielsen Norman, who took these studies in consideration and other studies as well. And they said, interactive elements must be at least 1 centimeter by 1 centimeter to support adequate selection time and prevent fat finger errors. So at least 1 centimeter by 1 centimeter. That's what we're going to use for, let's say, a wide demographic of able-bodied individuals. And for the sake of this conversation, for this talk, our Goldilocks physical size that we want to get to is 1 centimeter by 1 centimeter. Okay. So we've discovered the physical side of things. 1 centimeter by 1 centimeter is what we want to do. Let's talk about the digital side. And this is where things get a little bit tricky, because we have a lot of different voices coming at us saying what to do. In particular, let's take a look at some examples from tech companies. WCAG, our accessibility brothers and sisters, they say use 44 by 44 CSS pixels. And that should be large enough for your devices. Okay, that's it's a little bit bigger than 40 pixels, what I've heard before, but there's not much guidance in there. Google, they say use 48 by 48 dips, which for all intensive purposes is the same as a pixel in our case. 48 by 48, which will result in about 9 millimeter size. So Google shouts out, hey, we acknowledge that it should be around 1 centimeter big, but they just shout out a number saying 48 by 48. But where does that come from? And we'll talk about that. Apple says 44 by 44 for all of their controls. And they're assuming, obviously, that all your devices that you're designing for are Apple products. And so it gives them a little bit of leeway. But ultimately, we have different people saying different things. So first of all, there's not cohesion in saying exactly how many pixels are needed for 1 centimeter. And not only are they not the same, they don't really tell us too much about how to relate the digital side to the physical side of touch targets. A couple more examples. Here's Salesforce. They just say 44 by 44. Microsoft tells us 40 pixels by 40 pixels, but they give a caveat saying use 135 ppi, pixels per inch, and make sure that you're scaled at 1x scaling plateau or scaling factor. That may sound like gibberish to you. We'll talk about that too when I get to the actual solution. But just know, again, we have different people saying different pixel amounts, and Microsoft is leaning a little bit closer to the actual solution. We're relating physical and digital touch targets together. And Carbon from IBM, their design system says at 326 ppi, 90 pixels is equivalent to 7 millimeters. So use a 90 pixel touch target for this particular pixels per inch. So again, consensus, no one exactly says this is the gold standard. People are saying smaller touch targets like 7 millimeters as well. So what are we going to do with all this information? And we're going to talk about that next. Because something to think about is that we often design not for just one device. Sometimes we do. Sometimes we're saying, I'm going to design for this kiosk that all of the entire fleet for this customer, they're going to use this one brand. They're going to use an iPad brand kiosk. Or all of our users are using this particular smartphone. And if that's the case, then it makes things a lot simpler. But we are trying to design responsive apps. We're trying to design adaptive apps, things that will be able to flow and be fluid across multiple devices. And what's interesting is that if you, designers, you'll run into this all the time, is if you design a square that's 40 by 40 pixels and you design it for a smartphone size screen, if you then take that same design and then you mirror it onto an iPad or a larger device like a MacBook or a monitor, you'll notice that the physical sizes change, even though the pixels have not. Meaning, again, this orange dot, it could be 40 pixels on each of these screens, but in the physical world, they'll be larger or smaller depending on which device you're using. So what the heck what's going on here? Real briefly, why does this happen? This is having to do with resolution and scaling. So again, on a phone, you could do in this image, you can see that you can design something that's 24 pixels wide. And on a phone, it looks a certain size, but then by the time it projects onto a Surface Hub or a larger screen, that same 24 pixels has, again, suddenly increased in size. So we have to account for the resolution and sizes of the devices our users use. And this is the penultimate question. And this is the question we're trying to lead this all up to. We've decided that a physical touch target, that Goldilocks size from Nielsen Norman, it's 1 centimeter by 1 centimeter. Aim for that size physically. How many pixels is that? And the secret formula, drum roll, is here. 1 centimeter in pixels is equal to the height, your resolution in pixels squared, by the width in pixels squared, and you square root that. You take that and you divide it by the diagonal length of your device. You multiply it by something called the scaling factor. Then you take that whole thing, and if you're using inches as your diagonal length, you're going to multiply it by 0.393. End of conversation. No, I'm just kidding. It'd be fun if I just did a mic drop and left. We're going to break this down a bit. So what the heck is going down here? So breaking this up, first of all, we're going to take the numerator of that fraction, the height in pixels squared plus the width in pixels squared, square root. How do you find the width in pixels and the height in pixels? You can go to the manufacturer's website to determine how many pixels there are. You can look at other third-party websites and apps that let you know what is my resolution for this device. And that's all you need. If you have the resolution that is equal to the height and the width in pixels. And what are we actually doing here? Why are we squaring it and taking the square roots? We're using the Pythagorean theorem. So think back to your trig days in 8th or 9th grade, whenever that was. And you're using the theorem, a squared plus b squared equals c squared. And by doing this, you're calculating exactly how many pixels exist on the diagonal of that device, of that specific device, not all devices, that's related to that particular device. So we've done that. Now we know exactly how many pixels exist on this diagonal. The next step, before I move on, be aware, devices have different resolutions and different scaling. So I'm currently working on a MacBook Pro, and the actual device has a total of 3,072 pixels available, and across, and 1,920 pixels down. That's how many physical pixels exist that Apple physically put onto the screen. Now, all of those pixels are being actually scaled down. So if I went into my settings and I went into my display settings, I would see that the default resolution is actually a scaled resolution that looks like 1680 by 1050. So for all intensive purposes, my device, this MacBook that I'm working on, is using a resolution of 1680 by 1050. It's not using every single pixel that is available in the native resolution in the same way that we think about pixels when we design, but it's actually scaling it down. And why does it do that? The reason why we scale down our devices is so that we can have sharper images. If you've heard of retina displays, it's basically saying instead of making a circle equal 1 pixel by 1 pixel, in that same circle, I'm going to put in a bunch of extra pixels to make it more, make a sharper, cleaner image. And it makes that display really pop and make it really pleasing to look at. And I'm sure as technology evolves, we're going to have bit larger and larger native resolutions, but those are ultimately likely going to be scaled down so that we can have sharper images and more visually pleasing images. So that was just a caveat on your resolution. Be careful of which resolution you use. Now, next, we're going to look at the diagonal length. And this is often the length that, or the size of the computer that we, or whatever device is being used. So if you ever hear, oh, I got the 15-inch versus the 16-inch computer, what they're actually talking about is the diagonal length going from corner to corner, not just straight across, but actually diagonally across the screen to determine what the size of that particular device is. In my case, I'm using inches to measure this because at least in the United States, we use inches. And so most commonly when we talk about devices sizes, we're talking about terms in inches. And what we have done, since we've already determined how many pixels exist on that diagonal, and we know the physical size in inches, how many inches is on that diagonal, we're dividing pixels by inches, or PPI, pixels per inch. We've already calculated the pixel density in this formula. So hurrah, you did that, and that's actually an important factor for determining scaling factors, which is the next step. Scaling factor. Now, this is probably the most tricky component to realize because different manufacturers have different standards for scaling factors. The easy answer to say is if you want to find your scaling factor, either look it up online by going to the manufacturer website, or you can use apps. For example, there's an app called What's My Device on Android that will do this for you and just determine what the scaling factor is. A quick note, Apple likes to have scaling factors of 1x, 2x, and 3x. And for the designers who are experienced with this, I'm sure you are familiar with taking an image and then giving the developers a 1x version of that image, a 2x version of that same image, and then a 3 times big scaled version of that same image. And this again has to do with handling different native resolutions and scaled resolutions to make things look sharper across different devices. Android is a little bit trickier. Feel free to ask me questions about that or reach out to me after to talk about their unique scaling factors. But just know that Android, in addition to having 1x, 2x, and 3x, they have 1.33x, which is known as TV dots per inch. They have 1.5 device scaling size, which is known as HDPI. And then they also have a 4x for some of their huge, larger screens. So scaling factor, that's part 3 of the equation. And then last but not least, because again, we're dealing with device sizes in inches, we're going to multiply this whole thing by 0.393 inches. And why are we doing this? The reason why is because 1 centimeter, which again is our gold standard, 1 centimeter is equal to about 0.393 inches. So again, we're just basically converting from inches to centimeters in this situation. If you were measuring the diagonal length of your screen in centimeters, then you would not have to do this final step, and this would not be required. Whew. Okay, so this gives us our Goldilocks equation for determining digital touch targets. This is how we determine how many pixels are in 1 centimeter. This is the ultimate goal. Instead of just going for 44 pixels or 48 pixels by a particular design system telling us to do that, we are calculating it for ourselves for a specific device and for a specific user. But why? Why bother? Much math, very numbers. It's a lot of work to do, especially if we're designing for a lot of different devices. We just have to remember, why are we doing this? We want less of this. That's what it comes down to. We want less of people squinting to try to find the right touch target, trying to use their finger or use a stylus to interact with our touch targets. And we want more of this. We want more of the celebration or just ease of use. Our software should be really enjoyable to use. It should not cause frustration to use. And we do this by making sure the things we design and the things that we actually implement can be used by our users and can be used in a way that's very intuitive for them and easy to touch, easy to interact with. So let me give you guys a real life example that I ran into recently. I've been working on this product called Worklist for one of our customers. Basically, this is an example where the customer said, we're going to outfit our fleet with these Samsung Galaxy 8-inch tablets. Every one of our conductors is going to have one of these. They're going to use this to manage their operations and track their progress as they complete tasks on their route. So I was given the task of designing for this particular device, and I needed to know what is the smallest size in pixels of a component should I make. So if I'm making a button, or if I'm designing a button, should I just make it 40 pixels and just move on? Or should I actually make sure that I'm getting that 1 centimeter by 1 centimeter size for the components that I design? And just to walk through this, using this as an example, the first step was finding the resolution. I did this by looking this up online. The resolution was 1280 by 800, and so I plugged that in. Second step was to find the device size. This was easy to do because I have a tape measure, but also you can find this in the name, the Samsung Galaxy 8-inch tablet. So there it goes, 8 inches. That's my number. Scaling factor is the third step. I found the scaling factor using an app called What's My Size? And I also confirmed this online. This particular device uses that unique TV DPI, which means a scaling factor of 1.33. And last but not least, because I measured in inches, 8 inches on this tablet, I multiplied by 0.393 to convert it to centimeters, getting that 1 by 1 centimeter size touch targets. And once you plug in all those numbers and you do all the math, the number of pixels in 1 centimeter for this device, 56 pixels. Now note, 56 pixels is not 48 pixels. It's not 40 pixels. It's nowhere near those. It's 56. And also, we have to ask ourselves, like, why is this important? Sure, just design a 56, whatever. No, 56 pixels now becomes the building block for how I design stuff. So example, if I need to have a row of navigation, do I want to go less than 56 pixels? If I do, what are the ramifications for that? Is it going to be harder for the users to actually interact with because it's less than the recommended size? If I go twice as big, what does that do? Does it make it doubly easy for the users to do? Or do I just know that now I have some buffer? Anything above 56 is going to be good. Ultimately, 56 becomes like the atom in your atomic design for determining what your interaction area should be. So, and that using that size, you can then scale up to all the different components that you want to put on your screen. And of course, I'm talking about interaction areas. If I was just wanting to put a table down for the users to see a list of rail cars, for example, do I need to use 56 pixels for each individual row? Absolutely not. 56 pixels is equal to 1 centimeter on this device. And that means that if I want the users to touch and actually select one of those rail cars, I should maybe consider 56 pixels. But if I'm just trying to show data, I can go less than that. I'm not bound by the 56 pixels in that regard. I'm just saying, for the sake of when I want the users to touch the screen, I should be really careful about going less than 56 pixels. Yeah, and as I said, like, again, all these different design systems, these different companies are providing different numbers or values to say use 44, use 48, use 90 pixels even. It's not about the pixels, it's about the device. And in this case, this device is 40 pixels. In this case, is like half a centimeter. It's like really small. It's less than all the recommended touch target physical sizes of things. So the moral of the story is it's worth doing the math. Do the math for your users, do the math for yourself so that you know that everything that you design is going to be appropriately interactable and ultimately lead to a great experience. But it's too much math. I know what you're thinking. It's too much math. It's a lot to do, especially if you have like 10 different devices you have to account for. Well, not to worry. The first step is to make sure that you're designing for the smallest device, and obviously the larger the device, the bigger it will be. So one, all you need to know is your smallest device that you want to use this on. And two, I made it easy for you. I actually developed a little calculator that is on my website. I'll show that real quickly and go through that example. So let me go over here. So we have this pixel calculator. And again, all you need to do is put in the information. So in my example, for my tablet, I had a height of 1,280 pixels. I had a width of 800 pixels. I was measuring in inches, and the size of that screen was 8 inches across the diagonal. That gave me a pixel density of 189. And oh, I forgot the scaling factor. Scaling factor is 1.33. That gives me that 56 pixels magical touch target size. That's my Goldilocks. That's my ultimate atomic size. That if I want to make something 1 centimeter by 1 centimeter, I need to make sure that it's 56 by 56 pixels wide. Cool. So I'm going to jump back to the presentation here. So you have the tools, you have the knowledge, you have the ability to do this and do it in a quick way now that you have a tool to do this. So to summarize, and real quick, Archie, can you confirm that you can see the presentation?
Yep, we can.
Awesome, thank you. So to summarize, first of all, you have to decide. Decide for yourself that you want to not rely on what other people tell you, other companies tell you to be the optimal touch target. Don't just rely on 40 pixels being that size. Don't rely on 48. Make sure you're actually designing for the users and the hardware that they are interacting with. 2, device. Again, yeah, be aware of what they're using. If you're designing for a big widescreen, a huge widescreen that would be on like in a arena or something, or you want like one of those tall interactable kiosks that you see at like an airport where you're trying to find a map. Know what the resolution and the hardware is actually going to be used for that user. It doesn't make sense to design for a smartphone size if the only thing that the user is going to interact with is 8 feet tall. So again, be aware. Because if you were to do that situation, even though the orientation is the same thing, a button that is 40 pixels on a phone is going to be huge. It's going to be like, I don't know, half a foot tall on the larger 8-foot kiosk. So be aware of the hardware that your users are utilizing. Calculate. Use a secret formula. Use that pixel calculator. Find out how many pixels it takes to make 1 centimeter for that device. And then finally, design. Go forth, be armed with that knowledge of what is that Goldilocks pixel unit, and use that to build out the rest of your design. Make sure that everything that you want to be interactable is easily interactable and large enough. And be aware of the items that you want to be smaller than that interaction space. And just to have that knowledge and that to make you a more effective and yeah, just be a more effective designer as well. So with that, I say go forth, go design, and I'd like to say thank you for listening to my talk. Do you guys have any questions? I'd love to answer them.
Nice, thank you, Tony. I love how exhaustive this was because I've always sort of heard the 40 pixel rule and never knew where it came from. Turns out it's just a rule of thumb and doesn't capture the essence of this. So I've already bookmarked your calculator. Thank you for that. Just one quick question, and I understand that the calculator is used for determining the smallest pixel size, whatever equates to 1 centimeter by 1 centimeter. Is there an easy way to like scale that up via like the Goldilocks principle? Is there a way I can determine what would be a good medium based off of that, or a good large size, or is that just sort of, go with my gut type of thing?
So just trying to make sure I understand what you're asking. So you're saying this calculator is great for figuring out the smallest size, but how do I make sure that the design scale well? Is that the question?
How do I guess, how could I estimate like an appropriate medium size or large size button at that point? I don't know if my question's totally appropriate for this. I
Yes. Okay.
understand finding the smallest, but I didn't know if there was like a simple way to say, okay, well, if it's, 68 by 68 for my small, what should my medium be?
Absolutely. Okay. So yeah. So if I have I can get the small size, that's great. But if I want t-shirt sizes for a medium sized button or a large size button, how do I do that? And the answer to that is it really depends on one, your design system that you're using, because and also the devices that you're using, I would say, because if my medium size is targeted to a particular device, let's say my small size is a smartphone, and then my medium size is a kiosk, like that 8-foot tall kiosk, and then my large size was this arena, for example. Kind of a crazy example, I know, but with that in mind, if that's your medium size, then your medium size might be different than what you would consider on, say, like a laptop or something. So it's a combination of knowing what devices you're going to be using to determine what actually makes sense in the real world. And it's ultimately up to your creative influence. I don't think that there's a set gold standard for saying 1.5x is a good medium size and 2x is a large size, because it really depends on design system. It depends on what kind of interactions you want your users to take. So if I'm on an e-commerce website, my small button might be a small settings icon, and then the medium size button might be more related to like an entire card to click on a particular product. So all that to say, I would say it depends on your hardware. It depends on your design system. There is not to my knowledge, a gold standard to say 1x is medium, 2x is large. You just have to use your best design judgment.
Nice, thank you. Yeah, that makes sense. I figured that was probably the answer, but good to hear it from the source. Thank you.
Yeah, absolutely. All right, Eli, I see your hand.
Hey, Tony, awesome presentation. I love the perspective of how you went in depth into explaining each specific state and didn't kind of like just comb over it and kind of like proceed to a number. I love the example and execution there. So kudos to you on that. My question, so when early on when you were referencing some of the patterns that some companies are using and some of the execution or space usage of space within their executions, did you do any reading on or kind of like any research on like say for example like how they're creating these dark patterns, like your example in TikTok where it's like it's interesting that they make you stop there and then hey, that pop-up is basically to add more friends, that equaling more time on the application for more discovery, versus like another example, if you use LinkedIn, when you click on a mobile device, when you click on your profile picture, it has this tiny little space where like, yeah, you can look at your own profile, but you can look at settings. And then if you don't have a pro LinkedIn, it kind of forces you to kind of go into the pro LinkedIn settings. So just wondering like if you kind of combed or did some research on that perspective from a dark pattern element.
Yeah, so when you say dark pattern, you're saying the like not just negative space, but you're talking about how like are you talking specifically about colors or just talking about
no, anything. So like I know that on one of our previous talks when Andy was here, he was talking about like the whole beard wax, how he went to the site, for example, and it says only 5 left. You refresh the page, only 2 left, or like sorry, like only 7 left. So they're kind of lying. So that's one instance of dark patterns where it's like it's just kind of like fake messaging. But then also in this instance is like another dark pattern that many companies kind of do is like maybe they create this space or limitation on interactionable space because they want to kind of have you go in another direction to kind of like influence you to spend more time. So I'm just wondering if you kind of read up on any of that as you were kind of building this presentation.
No, absolutely. So what I will say is that while I could not find TikTok specific design system guidelines or LinkedIn for that matter, since some of those design systems are private, that said, the design systems that I have looked at do relate more to the like here's what you should do, and they don't necessarily always talk about those negative spaces, meaning they don't necessarily say how to engineer a tough interaction. They're all about it's tough enough, so let's make it as easy as possible. And so that's a good point. If I do find readings or if you do find stuff, please let me know, because engineering for failure is an actual thing. I do know about, for example, in wind turbines, when they're building wind turbines, at the very base, they have like all the electronics that then feed into the main grid, right? And when they, in order to protect the employees or the crew guys who go out there to repair those wind turbines, they really don't want to touch any of those electrical wires. Touching that would be instant death. And so what they do is they engineer methods of barriers to make things more difficult for the crew members to actually go and open up those bolts. They have like 3-inch metal plates that have a bunch of screws that have Loctite on them. It's like, never open this box. And if you do, you really have to consider what you're doing. So it's like an engineered for difficulty in order to protect the users. So when it comes to our design systems, it's the same thing. I haven't found as much reading on how to design things to make things difficult for users in specific use cases, but it's a very valid point or part of design that we need to consider in our stuff. And so, yeah, if you find anything, let me know, and vice versa, I'll share that.
Absolutely, and it goes in line with knowing your user. I mean, many of our users, you know, they're wearing like these heavy gloves, and like hence why the space is larger for interaction as well. Some of the instances there, like again, like, you know, I'm just interested in finding how these different brands, how they know their user, and, you know, in their states, etc. So yeah, no, awesome. Thank you, man.
Cool. All right. Any other questions? I love the questions that you had so far.
Come on, people, show some love here.
Hey, Tony, a great presentation. Definitely learned something from you. So, you know, the example you brought up, the TikTok, really kind of like brings my interest in, because I wasn't really a TikTok user. So I definitely see that close icon extremely small, right? And I definitely see this kind of instance in other applications too. So I just wondering, so when you interact with it, is just the icon itself looks small, or the touch target is actually small? Because that actually brings a question to when you do the visual design, you're trying to find the trade-offs, right? So you don't want to making your close but extremely large. You just look nasty on a small screen, but also you want to making sure that it's easier to touch, right? So how we find the best trade-off, or is there gonna be a good scale? Let's make the icon 24 by 24, but the touch the touch target is actually 40. So, you know, that's just kind of something I'm interested to see how you thought about.
No, that's a really good point, because yeah, the difference between what we see versus what we actually interact with are not always the exact same thing. Like obviously in Google Material, it says use 24 by 24 dip pick like icons, but have the interaction space be 48 by 48. So anywhere within that 48 by 48 invisible square will be able to click and be able to interact. So definitely, I did not include that as part of this talk. But when we talk about interactions, yeah, find your magical Goldilocks pixel size, and that can be the interaction space. You can have a smaller icon inside of that to guide the user, but ultimately when you interact, if you want it to be 1 centimeter by 1 centimeter, use that Goldilocks. So in this example at TikTok, it seemed that their interaction space and their icon size were exactly the same, or very, very close. And so that's why I kept on tapping and having issues with getting that close button. If they had expanded the interaction space to be like larger down here, I would probably not have had that same issue, and I would have been able to close it. Or better yet, even be able to click outside of the modal to be able to close that modal itself. So yeah, you bring up a really good point, Murphy. So when I'm talking about your Goldilocks size, that's your interactable space. It's not necessarily the full size of the button, for example. As long as you have the padding around the button, that's gonna equate to triggering that action. Great question. Yeah.
Hey Tony, I have a question. This is Kayuri.
Hey, Kiri, go ahead.
Hi. Firstly, the presentation was lovely. I learned a lot. So I wanted to know, when you want to close something. So for example, your TikTok example, if closing that, sometimes it's on ads. and things that the client like strategically doesn't want people to find fast. Just part of the blueprint of the app in advertising. So do you think like an ethical angle comes in here, and can you use the golden rule to then push back as a designer? I just want to know
That's
your thoughts on that.
that's I love that question, and it actually relates back to what Eli was talking about with these negative actions, I guess, or the dark ideas. So yeah, if you want to bombard the user with an ad that you can't close, is that ethical? In my opinion, no. And ultimately, it's kind of related to how that business wants to target itself and how we want to behave. But I would say that if I had the opportunity to choose, then yes, absolutely, I would say, hey, ad revenue is important, but are we providing a service to our users? Is the ad why the user came there? Probably not, in my opinion. And so with that in mind, yeah, you could use the interaction space saying, hey, this button is either like too close to other interactable areas, it is too small and it can't be seen, and we want to make it fair to the users to get out of it. And it ultimately boils down to how do you want to design? And you can definitely use this to arm yourself, saying, if that particular corporation or company was like, oh, we have a close button, it's there. We fit the minimum requirements. You could say, no, we actually need this to be accessible to our friends who have accessibility issues, and to those who don't, who just want to get back to the page. Make this size 56 pixels or something, and make it more accessible. That would be my take on it. Yeah, your personal ethics and the company's ethics, that's a whole other ball game, but that's what I would say.
Okay, thank you. And I actually have another question. I don't know if anyone asked this, I missed a little bit of it, but I'm really curious as to how something like this would translate to when you're using a cursor. Would the touch target shrink considerably just because it's pointed?
Yeah, that's a great point. And I'm going to actually jump to this other screen that I looked up, which was hilarious to me. Bear with me. Yeah, there are creative solutions, I will say, for people trying to deal with small touch targets. For those who remember like the old like stylus, or even some new phones still have the stylus that pops out of your phone, or like these gadgets to let you touch more easily. I would say that from the more common use case is that people do not have these extra accessories, and so we should design for physical touch via finger. But that said, yes, this design or this conversation is really focused on the mobile side of things. If we're talking about cursors, cursors are great at being able to select a 1x1 pixel unit. And so the requirements aren't as stringent, but I would say because things are turning more mobile, my recommendation is to design for, again, larger touch targets. And if the user wants to access this just via a mouse and keyboard, great. Their touch targets will be large, like more than large enough compared to your finger touch targets to get success on whatever you're designing.
Okay, thanks, Tony.
Yeah, thanks for the question.
You mean the nose stylus, Tony?
What type of stylus?
There's a nose stylus.
A nose stylus.
A long nose to type with the nose.
I should.
Well, does anyone have any last small questions for Tony? We have a couple of minutes to kill, if that's the case. If not, we can do our wonderful monthly photograph. Seems like nobody does. All right. Well, thank you, Tony, for a lovely presentation. It was awesome, and I can't even explain it. It was awesome. Thank you for doing this. Thank you for sharing your knowledge and being a part of Creative Wednesdays. You were the first person to be like, yeah, I'm going to do it. So that's awesome. To everyone else, got to work up to Tony. All right. Well, if no one has any other questions, why don't we all get on screen so we can take lovely photographs? Woo woo. You know the drill. All right. I'm going to stop recording.